Okay, so by now we know that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. In this video, we're going to talk about the reciprocal functions. The reciprocal functions are your cosecant, your secant, and your cotangent. These functions are the reciprocals of the sine, cosine, and tangent. So the reciprocal of the sine is the cosecant. So if the sine is opposite over hypotenuse, the reciprocal of that is hypotenuse over opposite. The reciprocal of cosine is the secant. So if the cosine is adjacent over hypotenuse, then the reciprocal is hypotenuse over adjacent. And the reciprocal of tangent is the cotangent. So the cotangent is adjacent over the opposite. So if I can identify the sine, cosine, and tangent, then the cosecant, secant, and cotangent are very easy to identify because it's just the reciprocals of the sine, cosine, and tangent. Because the cosecant, secant, and cotangent ratios are reciprocals of the sine, cosine, and tangent, they are called reciprocal functions. CSC is the abbreviation of cosecant, and that is equal to 1 over the sine. SEC is the abbreviation of secant, and that is equal to 1 over the cosine. Now remember, we have to have an angle. Theta just represents the angle in all of these. So every single one of these has a little theta. Theta just represents that angle. Before, I'm sure you've seen it as A. I just need to have a theta represented some angle. I can't have it by itself. The COT is the abbreviation for cotangent. So the cotangent is equal to 1 over the tangent. And again, I have to have the theta there. Okay? And again, the theta just represents whatever angle that I'm using at that time. So it's just a placeholder is all it is. Okay? So we're going to find the 6 trig functions for this example, and we're going to find the exact values, meaning we're not going to actually use decimals. So we're going to find the sine, cosine, and tangent of theta, the cosecant, secant, and cotangent of theta. Remember, these 3 functions are reciprocal of these 3 functions. So if I find these 3, the sine, cosine, and tangent, then finding the cosecant, secant, and cotangent are very simple because they're just reciprocals. Okay, so what we're going to do is we're going to start by identifying the adjacent, opposite, and hypotenuse of theta. So based on theta, 12 is the opposite, 5 is the adjacent, and 13 is the hypotenuse. Remember, the sine is opposite over hypotenuse, so 12 over 13. The cosine is adjacent over hypotenuse, so 5 over 13. And the tangent is opposite over adjacent, so 12 over 5. Reciprocals. The sine is the reciprocal of the cosecant. So if the sine is 12 over 13, then the cosecant is 13 over 12. I just write the reciprocal. I flip the fraction. the cosine and the secant are reciprocals. So if the cosine is 5 over 13, then the secant is 13 over 5. And the tangent and the cotangent are reciprocals. So if the tangent is 12 over 5, then the cotangent is 5 over 12. And it's as simple as that. Next example, again, I'm going to go ahead and start by identifying opposite, adjacent, and hypotenuse. So based on theta, 4 is my opposite, 8 is my adjacent, and 4 square roots of 5 is my hypotenuse. So my sine is opposite over my hypotenuse. My cosine is my adjacent over my hypotenuse. And my tangent is my opposite over my adjacent. I am going to reduce these fractions, and if you notice, I do have a radical in the denominator, so I am going to rationalize these. But before I rationalize, before I reduce, actually before I rationalize, I am going to find the reciprocal. But I am going to go ahead and reduce first. So to reduce, my 4 goes with my 4, so I'm left with 1 over the square root of 5. The reciprocal of that is the square root of 5 over 1, which is simply the square root of 5. 4 goes into 8 2 times, so I have 2 over the square root of 5. The reciprocal of that is the square root of 5 over 2. And of course, 4 over 8 reduces to 1/2. The reciprocal of 1/2 is 2 over 1, but we're going to write that just as 2. Now, since I did not rationalize first, once I did the reciprocals, these don't need to be rationalized. But I do need to go back and rationalize these two because I cannot leave the radicals in the denominator. So let's look at what that looks like. So 1 over the square root of 5. When I rationalize this, I have to multiply it by the square root of 5 over the square root of 5. 1 times the square root of 5 is the square root of 5. The square root of 5 times the square root of 5 is the square root of 25. The square root of 25 is 5. Remember that when I multiply a radical by itself, I always end up with whatever's inside the radical. So this is going to be the square root of 5 over 5. Okay? When I rationalize 2 over the square root of 5, I have to multiply it by the square root of 5 over the square root of 5. So I get 2 square roots of 5 over 5. I'm going to erase in here a little bit just so I have a little bit more room to write. So I'm going to erase if I can. Yep, there we go. So this ends up being 2 square roots of 5 over 5. Okay, so let's look at like one more example of this. Okay, with this one, I'm still going to go ahead and label my triangle with opposite, adjacent, and hypotenuse. So based on where theta is. So right now theta is here. So this is opposite, adjacent, and hypotenuse. Notice I don't have the hypotenuse, so I actually have to solve the Pythagorean theorem. A squared plus b squared equals c squared. So 6 squared plus 6 square roots of 3 squared is equal to c squared. 6 squared is 36 plus 6 squared is 36. The square root of 3 squared is 3 is equal to c squared. Because remember, the square root takes care of the squared, and I'm left with what's in the middle. So 36 plus 108 is equal to c squared. 108 plus 36 is 144. And the square root of 144 is 12. So my hypotenuse is 12, which is nice because that's a nice even number. Okay, so I'm going to look for the sine, cosine, and tangent first. So the sine is opposite 6 square roots of 3 over hypotenuse. the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. I am going to reduce these. 6 goes into 12 2 times, so this is the square root of 3 over 2. The reciprocal of that is 2 over the square root of 3. We're going to have to rationalize that here in a second. I'm going to wait though. 6 over 12 reduces to 1/2. The reciprocal of 1/2 is 2 over 1, but I would leave that as 2. The 2 6's divide out, so I'm left as the square root of 3. The reciprocal of the square root of 3 is 1 over the square root of 3, and I'm going to have to rationalize that too because I cannot leave the square root of 3 in the denominator. So I do need a little bit of room over here, so I'm going to erase where I did the Pythagorean theorem to find my hypotenuse. Okay, so I'm going to rationalize 2 over the square root of 3. I'm going to multiply this by the square root of 3 over the square root of 3. So I get 2 square roots of 3. Remember, the square root of 3 times the square root of 3 is just 3. So this is 2 square roots of 3 over 3. 1 over the square root of 3 times the square root of 3 over the square root of 3. So I get the square root of 3 over 3. So this is equal to the square root of 3 over 3. Okay, so that's just a quick example of the sine, cosine, and tangent and how it relates to the secant, cosecant, secant, and cotangent. They're just reciprocals. If you find one, you can find the other.